Hello all. This is Unit 1, Introduction and Simplification of Boolean Expression. In this chapter, we'll explore more about number systems and number system conversions, logic gates, Boolean algebra, and K-maps and all fundamental concepts in digital electronics. So as I said, the first topic is number system. And there are four different types of number system: decimal number system, binary number system, octal number system, hexadecimal number system. Here, binary number system is the most essential in digital systems because it uses only two symbols, zeros and ones, to represent all data. Now, let's see about the number system conversions. So, here, let's say you're given a decimal number and you have to convert to binary. You have to divide the given decimal number by 2 and record the reminders. Like, for example, 45 is the given decimal number. Now we are dividing it by 2 until it reaches the remainder 1. So now at the end, you have to write the given reminders from bottom to top. Like for example, 1, 0, 1, 1, 0, 1. Now this is the binary representation of the given decimal number. Now let's see how to convert a binary number to decimal. So we have to first note down the place values. Like for example, this 0 has the place value of 0. This one has a place value of 1. And next one has a place value of 2. Next 0 has the place value of 3. And next one has the place value of 4. Now we're multiplying the given binary number into 2 power the place value. Like for example, 0 into 2 to the power of 0, because this 0 is the place value of 0. Next 1 into 2 to the power of 1, like the entire binary values, and then we are finally adding the multiplied values and we'll get the decimal number. So for this binary value, the decimal number is 22. Next, we are converting the given decimal number to octal. For that, we have to divide the given decimal number by 8. Since we are converting it to octal, we have to divide it by 8, and then we note down the remainder values, and then we are writing the remainder value from bottom to top. Next, we are converting the given octal number to decimal. For that, as I said, we have to note down the place values. For example, 1 is in the place value of 2, 4 is in the place value of 1, 5 is in the place value of 0. So 1 into 8 power 2, 4 into 8 power 1, 5 into 8 power 0. Next, we are totally adding after multiplication and the noting down the given final value. So for the octal number 145, the decimal value is 101. Next, if we have to convert a given decimal number to hexadecimal number, we have to make sure to write the hexadecimal to decimal conversion first. Like for example, for the decimal number 0, hexadecimal number is also 0. For decimal 1, hexadecimal is also 1. The decimal and hexadecimal values is same for 0 to 9. Like decimal values from 0 to 9 is also hexadecimal value 0 to 9. But when it comes to the 10th decimal value, the hexadecimal value will vary as A. And for 11, the hexadecimal value is B. For 12, the hexadecimal value is C. For 13, the hexadecimal value is D. And for 14, the hexadecimal value is E. For 15, the hexadecimal value is F. Now, let's see how to convert a decimal number to hexadecimal number. Now, let's take an example of 156, a decimal number. If you have to convert to hexadecimal number, you have to divide the given decimal number by 16. We have to note down the reminders, and then we have to convert the reminders, and we have to write down the reminders in hex value. Okay, so for example, 156 is the given number. We are dividing it by 16. The answer is, the quotient is 9, the remainder is 12. Then we are dividing the quotient value by 16 again. So the quotient is 0, the remainder is 9. Now we have to write down the remainder numbers from bottom to top. So 9, 12. So 9's hexadecimal value is 9. So we will leave the 9 as 9. But 12's hexadecimal value is C. So by writing the answer, 156 hexadecimal value is 9C. Now we have to convert uh, hexadecimal to decimal value. For that, we have to divide the given hexadecimal values as two different types. B and 4, two different hexadecimal values. For B, the hexadecimal value is 11, so 11, and for 4, the hexadecimal value is 4. Now, 11 into 16 power 1, because this is 0th place, this is in 1th place. So, 11 into 16 power 1 plus 4 into 16 power 0. So, after multiplying and adding, we note on the final value. So, for B4, the decimal value is 180. Now, binary to octal. Now, if you're going to convert binary number to octal, let's note down the binary value. Now, we have to divide the binary value into 3 bits, because octal, in order to convert the octal, we have to divide into 3 bits. So, 110 has a binary value. So, 110 has a binary value, and we have to convert into octal. For 110 in octal is 6, and again 110 in octal is 6. So the given binary values octal number is 66. Now if you have to convert octal to binary, we have to see the binary value of the individual digits. For 7, the binary value is 111. For 5, the binary value is 101. Now we write it together, 111 101. Next, binary to hexadecimal. So binary value is given. Now we have to divide the binary value into 4 digits for in order to convert hexadecimal. So 1110 is represented as E, and 1101 is represented as D. Now hexadecimal to binary means we have to hexadecimal values given. We have to represent the hexadecimal values in binary. So A's binary value is 1010, and 3's binary value is 0011. Now next is octal to hexadecimal. So in order to convert octal to hexadecimal, first we have to convert octal to binary, and then we have to convert the binary value to hexadecimal. So let's see an example. An example is given 157. First we have to convert each individual octal values to binary value. So 1 is represented as 001, 5 is represented as 101, 7 is represented as 111. So we will write it together. Now we group it into 4 bits. So 001. Since first let's see how many bits are here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are only 9 bits, but we have to pad it with 0 in order to get the final value. So we always pad it with 0 in the rightmost value and leftmost value. So 0001, 1011, 111000. We have paired with zeros, and we got the finalized value as 1, B and 8. Since we divide the hexadecimal values 4, 4 and 4, we got the binary representation to the hexadecimal representation. 0001 in hexadecimal is represented as 1, 1011 in hexadecimal represented as B, 1000 represented as 8. So our final value is 1B816. 1B8. 16 is the base value, that is hexadecimal value. Now hexadecimal to octal. In order to convert hexadecimal to octal number, we have to convert from hexadecimal to binary, and then binary to octal. So hexadecimal value is given 3F16. So 3 is binary value is 0011. Then F is triple 4 ones. Now we have the binary representation. We have to divide into 3 parts. So 000 111, again 111. So the representation is 077. 0 on the left side has no value, so we'll take the final answer as 77. Next topic is binary codes. So binary codes, the normal decimal digit is, in order to convert to binary code, we have to represent in 8421 for 4 bits. So when you add all these numbers, you have to get the decimal value. So 8421, first bit is 1, so we add 1 here. Next for 2, so 0010, because 2 is here, so 103, 0011. Now we add 2 plus 1. Now say 2 and 1, you have to get it as 3. Next for 4, 0100. So